So the setup here is the following. We have edge view of the plane, which is, well, projecting plane being perpendicular just to one of the projecting planes and not to two. Well, obviously you can't have it perpendicular to both three of them. That's impossible, but you can have it perpendicular to two of them, and that becomes the level plane. And we don't really care about the level planes for now. This is just an edge view of the plane which is perpendicular to only one horizontal, in this case, projection plane. To show you how it looks in 3D, that's the horizontal projection plane, that's frontal projection plane, and that's the projecting plane or edge view plane. In this case, it's labeled as alpha. Here we can see it's alpha. If you see just one line, if there is a line and it has this kind of thick ending and the Greek alphabet, even if it doesn't have any name, it means it's an edge view of the plane and it doesn't have the frontal projection. Well, why do we say that it doesn't have any projection? Well, if we had an oblique plane, just a triangle, we saw how that may look here, all right? But in this case, we can't really define this infinite space while looking from the front. It just doesn't work that way. But as soon as we look from the top, we can see its edge clearly, so it is defined in that case. Same goes for the side view. It's not really defined, so projecting plane or the edge view of the plane is already defined in the projection where it is perpendicular to. And in this case, we have a line going through this projecting plane, and we need to find its intersection. Well, the thing is, you cannot really find the intersection in certain views. It only works in the view where you can see the plane as the edge. It doesn't really work in the front view. If I position myself, well, now I can see it faintly, like so, there is an intersection there. But in other times, you will not be able to do it in like a diagram or something. In this case, I can't really tell where it is, but as soon as I position myself from the top and see it as a top view, I can clearly see where the intersection happens. If you look carefully, you will see how that is. So let's just see how that works here. That would be just put the point here, as this is an intersection. Oh, this is a large one, we don't need it. We can call it a name. Doesn't really matter. Let's call it point K, K1. And we know that this intersection point belongs to the surface and also belongs to the line N. So we can take a connection line up to, up to line N and give it a name. And we need to determine, or we may call it discuss, the visibility. So the visibility always happens, or the way it works, until the point of intersection. It is either visible and then it becomes invisible, or vice versa. So in this case, when I'm looking from the front, you can see this one faintly and this one more clearly. So here we can see that from the front it will be visible, and back here it will be invisible, therefore dashed lines. But how do I determine and how do I know on the diagram which one is which? So when looking from the top, the part which is farther away from the X line is visible. So in this case, here in this, anything in front of this plane, just not really for focus on the X line in this case. So things that is farther away from or outside of this area, right here, outside of this line towards me. By me, I mean farther away from X. That will be visible, and this part will become invisible. So let's show that here. So that's how it will look. Now let's move on to another topic. In this example, we have line M going through triangle ABC, or a plane which is defined points A, B, and C. It's not really difficult problem It's going to be solved in a way that we need the projecting planes, the ones that I just discussed here. We need to implement those kind of planes either in the front view or the top view, doesn't really matter. We need to construct them on either of the lines, well, it's the same line, but either of the projections of this line, either frontal or the horizontal projections. It doesn't matter, both of them will give you the same idea and same solution, so it doesn't really change much. So let's see, and I'll do it on the horizontal one in this case, and as I said, it doesn't matter. So how do we construct a plane on line M? We darken the one end, doesn't really matter which end it is, and we write something like this, equals alpha 1. So this means we have just drawn a projecting plane aligning with this line. Now we need to find where this projecting plane intersects this triangle. Well, we can see it as in a top view, it's exactly the same thing. We are trying to find this line where AC line intersects this projecting plane, just the way we did here. So we just have to solve the same thing twice now. Nothing really changes. Here and there we have 2 points. Here, let's call it 1, 1, and let's call this one 2, 1. And we need to find its respective projections. Okay, let's see. So this one is AC, it will be here. This one is BC, we're resting on BC, so it will be somewhere here. And let's call them names. Should become 2 and 2. One, 2. Okay. This triangle got sliced, and that slice section or the cut line looks something like this. That's where it was sliced with this projecting plane. And on this projecting plane rested a line. Well, every line which rested on this projecting plane went on some point here on this red line, which is, well, the cut section, okay, intersection. And one of those lines was the original M line. So that means this is the intersection. That's where the intersection happened. We need to mark this point, obviously. Give it a name. Let's call it point K. Most of the time we designate the intersection with point K. Not always, it doesn't have to be, we just do it for some reason. If you like the other one, you can use the other one, it's okay. And we need to find its projection down here. It's going to be on, well, line M. So down here we take this, call it a name, K1 in this case. And now we need to determine the visibility or discuss it. How does it look? Well, part of it will be visible and the other one will be invisible, obviously, until the point of intersection. And how do we define it? If we are working on the front view, the visibility on the front view, we need to determine it from the horizontal or top view, and vice versa. In this case, I'm going to work out the visibility here on the horizontal projection view, and I need to determine it from the frontal one. So the rule of thumb is, so I need to determine where it when the lines seem to intersect with the edge of the triangle. They don't really intersect, but on the diagram it looks as if they're intersecting. So let's see. It's like two skew lines. We need to find out which part, like is point AC or line AC on this connection line higher or like farther away from X line, or point 1. Or this line on point 1. So let's determine it. Here is line M on point 1, or on the connection line which goes through the point 1, and here is line AC. line AC on point 1 is much higher than this point on the same connection line. That means this edge is covering this part, this line. Therefore, this part will be invisible from here to here. This will become invisible, like this. And the other one automatically becomes visible, because, well, that's how it works. And next, in order to find the visibility here, we need to determine it from horizontal. So let's take any intersection. We can either work it out from here or here, doesn't matter. I'm going to use maybe this one. Let's draw a line, connection line, doesn't matter. I'm going to give it a different color. So on this pink line, I need to determine, is line M farther or line AB? So let's see. Here is the pink line. First, I see AB on this connection line. Then I see line M right here. That means line M on this connection line is closer to me or to my eye than AB. Therefore, this line will be obscuring. So from here, it will be visible because it was obscuring AB edge, and this will become invisible until it goes out of the edge. Like so, okay? That's the solution. Quite a simple one, that is. Okay, and same thing would be applicable on if we used projecting plane here on this line, or this projection of the line. We would get exactly the same intersection. So with that said, let's now move on to the intersection of planes. And in this example, we have a triangle piercing the quadrilateral, or vice versa. They are just intersecting one another. It's almost the same idea. We need to, well, find the intersection line, and we do that also with using projecting planes. It's very like kind of random. You can pick any edge and construct it there. It's the same way it works from the front view or the top view. Same idea. If you have the good spatial awareness, you can actually determine, or like prematurely know which lines you would rather have the projection planes constructed on. But if not, any combination will work actually. So we start from or by constructing projection planes. So the idea is, if you project or construct two planes on this one, you should get the intersection line. So let's just construct the plane. I'll use the different color actually to show that this also, we are getting the plane here as well. Let's also give it a name, alpha 1, and we need to find its intersection with quadrilateral ABCD. So it's the same idea. Just forget there is a triangle now, just focus on this plane and these two edges which it, well, pierced. So let's mark these 2 points here and here, find their intersection with respective. So A, B, it should be here. There it is. And this is on CD, and it should be here. Now let's mark the points, give them the names. And by the way, this will be on the midterm, so it would be nice if you paid attention to this problem especially. So we have enough information for now to construct this point of intersection, like so. So we know that QR edge pierced this quadrilateral in this spot right here. So let's mark it real quick. Here is where the intersection happened. Like so. Let's also give it a name. I'm going to call it M. Let's find it down here, or name it M1. And now we need to find second point of intersection. The way it works, like finding the line or segment of intersection, you just need 2 points, no more than that. You can find infinite amount, but that's not really useful. You just need 2 points. So the next plane I'm going to use is going to be, well, really either of them. In this case, I'm going to choose, I don't know. So we have a second cutting plane going on this edge, and so we need to find PR's intersection with this quadrilateral. Let's try that. It might not be on the quadrilateral and might be outside, but we'll find it. And before that, let's give these points names just so we don't get lost. So this will become 1, 1. Oh, no, sorry. 2, 1. And this will be 1, 1. Like so. The next, yeah, we need to find this edge. So here and here are 2 points. On the exam, I will tell you which edges would be nice to construct the plane zones, just so you get perfect intersection and you don't have to find the points outside of the shapes. So I'll help you in that regard. So it's on AB, it should be on AB here. 4 is located on PR. So, I mean, not PR, it's located on CB. Here is CB. And if you pay attention, when we draw this line, now first let's just mark the points, just so we see better. 3, 2, and 4, 2. And now if you pay attention, if I draw this line, the same segment I drew here, and it gave me this intersection, it doesn't really intersect PR line here. So why that happens? Well, it happens because if you imagine them as the planes, they intersect at some point, but like this portion of these 2 planes don't really intersect with one another. But intersection happens theoretically outside of the shapes. So if I extend these 2 lines, if I intersect these 2 lines somewhere, let's just do that. They intersected here, outside of the plane. Well, I will try to give you the coordinates just so this doesn't happen. And that's the other intersection point. It's outside, but well, it can happen. Now what we do is from this point, well, which is point K, let's call it K. We need to draw a line. Let's give it a different color. And if this line is contained in both of the shapes, that's the part I need, the only part I need. So this is the only part that shows me the intersection of these two shapes. So let's erase this part, or rather let's leave it but give it a color. And let's give this one a name, which will be N2. That's it. And so yeah, we found the intersection. Only thing that's left is the visibility. But before we do that, we need to find point N and its projection on the horizontal projection plane. So point N is located on CB. It should be down here on CB as well. Let's give it a name. These two, we get, well, this line, and the intersection line is always visible. And I think I have it constructed here somewhere, just a moment. Yeah, here it is. So this is the front view, and this is the top view of what we just drew. It also has a side view, but we don't really care. So we need to determine which part is visible and which one is not. Like from the top view, we can see that this edge is hidden, and then this one becomes hidden. So we need to determine how that is worked out. And it's the same way. So let's try to find if which one is higher, AB or RP or PR on point 3, or connection line going through here. So here is RP. So let's just elongate this just so we see better. So on this connection line, here is AB, and then comes PR. So in this case, this triangle is overlapping. So this part will become invisible, just the way we saw there. Like so. Then we need to do the same for point 4 as well. Let's just pay attention which one is higher or lower. So here is point 4, there is a connection line. We need to discuss it for point C, or line CB, and again PR, which one is higher. So here is connection line for 4, here is CB, and then comes, like, here is CB, and then comes PR. So therefore, this quadrilateral will also be hidden here. Like so, and then the vice versa happens always. Let's give it, oh sorry, like this, and yeah, triangle will be hidden. Like if this part is visible, and we know it is, then this one will obviously be invisible. So yeah, this is the intersection, and if we give it a color, we can, well, do that as well. Well, I have done it here, which, yeah, you can see it's almost the same as this thing here. It's not almost the same, it's exactly the same. And the same way would be for the front view. We can, well, determine it, but I'm not going to waste time there. It's the same idea. So this part of the quadrilateral is visible, like this part. So therefore, triangle will become invisible. So it's exactly the same thing that we see here drawn on the diagram. So yeah, you can give it a color obviously and leave it like that. So yeah, that's how the midterm works. But yeah, I'll tell you quickly how you would determine the visibility on either points. So we take maybe this point, drop it down with a connection line. Let's give it a different color. So on this pink line, I need to ask myself here, two lines will seemingly intersect, BC and PR. So on this point, which is farther away from X line down here, down there on the horizontal projection line. So on this point, again, BC and PR. So here comes pink line, here is PR, then there is BC. So BC is visible. So it's obscuring the triangle right here. And the same works for each of the points. I just won't get into it right now. It's going to take me all the time and I'm going to beat the dead horse. It's not no use. So I hope this small guide was useful for you. If you have questions, you can ask me, no problem. And yeah, I'll see what video I need to record for the next time. So yeah, good luck.